From reactivity to bonding, size matters in chemistry. In this video, we'll understand atomic radius and ionic radius, and the trends they follow across periods and groups. Atoms are extremely small, so small that even a powerful optical microscope cannot see them. Because of this, we cannot directly measure the size of a single atom. Instead, scientists measure the distance between the centers of two bonded atoms. Half of this distance is called the atomic radius. Let's talk about what happens across a period, from left to right. As we move from left to right in a period, atomic radius decreases. Why? Because atomic number increases. Nuclear charge increases. The nucleus pulls electrons closer. As a result, the atom becomes smaller as we move across a period. In longer periods, especially those involving D and F subshells, this effect becomes more noticeable. In the lanthanide series, the gradual decrease in atomic radius is known as lanthanide contraction. This is an important concept and frequently asked in exams. Now let's move down a group, from top to bottom. As we go down a group, atomic radius increases. Why? Because new shells are added. Distance between nucleus and outer electrons increases. Nuclear attraction becomes weaker. So, atomic size increases as we move downward in a group. As you can see in diagram. Now let's talk about ionic radius. When a neutral atom loses electrons, it forms a positive ion or cation. The size of a cation is always smaller than its parent atom. Because loss of electrons removes the outer shell. Protons become more than electrons. Increased attraction pulls electrons closer. Example: sodium atom has a radius of 186 pm, but sodium ion has a radius of 102 pm. Trend of cationic radius. Across a period, size decreases. Down a group, size increases. But remember, cations are always smaller than their parent atoms. Now let's talk about the negative ion. When a neutral atom gains electrons, it becomes a negative ion or anion. The size of an anion is always larger than its parent atom. Why? Extra electrons increase repulsion. Electron cloud expands. Example: fluorine atom has a radius of 72 pm, but fluoride ion has a radius of 133 pm. Trend of anionic radius. Across a period, size decreases. Down a group, size increases. However, anions are always larger than their parent atoms. Let's lock this in. Atomic radius decreases across period, increases down group. Cations are smaller than parent atoms. Anions are larger than parent atoms and their size decreases across periods and increases within groups. Periodic trends aren't random, they follow nuclear charge and electron shells. If this explanation cleared your confusion, like the video, share it with a friend who struggles with periodic trends. Subscribe for simpler, exam-focused chemistry lessons. Bye.